ladies and gentlemen, welcome back for another round of Chemistry with Mr. Doolin. Thank you for tuning in. I appreciate it. Today we're going to take a look at types of bonding, and specifically we're going to look at a specific type of bond called a covalent bond. Now, for most of you, this is something that you are probably semi-familiar with, but we need to make sure that we shore up our vocabulary, that we're using the proper terminology, and that we understand exactly what's going on here with covalent bonds. So, first things first. A covalent bond occurs between two or more non-metal atoms. So that's what you want to get down there. A covalent bond is a bond between two or more non-metal atoms. All right? And so, for example, I'll come over here and I'll draw fluorine, right? And fluorine has 7 valence electrons. And so what I'm going to do is I'm just going to use dots to show the 7 valence electrons, and then next to it I will draw another fluorine, and again with 7 valence electrons. And so the sharing that we were talking about is a literal sharing of these 2 electrons. Now notice, if they are sharing them, then what can happen is those electrons count towards the octet, or towards the valence electrons of both of the atoms, because they can exist on either atom. And so what happens, and what we say, is that atoms share electrons in the bond to complete octets, right? And that's the octet, if you're not familiar with, that's when we've got our 8 valence electrons, all right? And so our covalent compounds, they're going to share, it's between 2 nonmetal atoms or more, and their atoms are actually going to share those electrons in the bond to complete their octets. Now, we call them, this is the way that we're going to refer to them, we call covalent compounds, right? They are called molecules, or compounds. And so terminology-wise, I'll call a covalent compound a compound, or a covalent molecule a covalent molecule. So when I say molecule, I'm inferring to you that I am talking about a covalent bond, right? If I say a compound, I'm inferring to you that I'm talking about a covalent bond. Now, the special things about, we'll start looking at properties here, is that covalent compounds, they can exist, so they can exist as any state of matter at room temperature. So as any state at RT there is going to be room temperature. And so that can be a solid, a liquid, or a gas at room temperature, and for our covalent compounds. Now, they also have very low melting points. They have low melting points, right? And so what I'm going to put in parentheses here, and what I want you to add, is they have low melting points because the attraction between molecules is not very high. And so if I'm looking over here, I've got molecule A, and I've got another molecule A over here. What we're talking about this attraction between is that these 2 molecules do have an attraction to each other, right? But that attraction for covalent compounds is actually pretty low. And so the melting points is pretty low. Remember, melting a substance, we're actually just going to spread that molecule out, and we have to overcome these attraction between molecules to get them to spread out, all right? And so they have low melting points because the attraction between molecules is very low or not very high, all right? Okay, another one is they are not conductors of electricity, not generally. Not conductors of electricity. Okay, and so they're not good conductors. Now, some covalent compounds, when we dissolve them in water, they do allow some conduction of electricity, but generally speaking, your covalent compounds, they're not going to be good conductors of electricity. All right? They are generally low electronegativity, right? Again, I'm going back to my periodic trends. Differences, and I'm writing this out because this is an important one, between elements. Right? And I'm going to give you a very specific number here, right? They are the difference there, and I'm going to put it as a delta En. That's how I'm going to abbreviate electronegativity. The delta En is lower than 1.67. Okay? So the electronegativity differences between the atoms is actually lower than 1.67. They don't have a high enough electronegativity difference from one to the other for them to actually pull electrons away from each other. All right? Okay, and so these are the basic things that we've got to know about covalent compounds. The vocabulary here, ladies and gentlemen, I went pretty slow on this because I want you to hear the vocabulary. I need you to get the vocabulary correctly down in your notes so that it goes correctly into your brain. All right, and we've got to start describing these things properly, okay? So if you have any questions, please have them written down. You can come to tutorials to get those answered. Otherwise, we'll go over them in class, and then I will see you there.